There is a hole in the universe. Not a black hole. Not a void. Something far stranger, a region of space so cold, so empty, so perfectly wrong, that the leading explanation, the one scientists won't say out loud at conferences, is that it might be a glitch. In the next 8 minutes, you're going to learn what the CMB cold spot actually is, why every conventional explanation has failed, and why a small but serious group of physicists believe it might be the most important anomaly ever recorded, proof that reality itself has an edge. To understand why the cold spot breaks everything, you first need to understand what we were looking at when we found it. About 380,000 years after the Big Bang, the universe cooled just enough for atoms to form. Before that moment, space was an opaque, superheated plasma. Light couldn't travel anywhere. Then, in a cosmic instant, the fog lifted, and light streamed freely for the first time. That ancient light is still traveling. It surrounds us right now, in every direction, a faint microwave glow called the cosmic microwave background, the CMB. It is, quite literally, a photograph of the universe as an infant. Every satellite, every telescope, every calculation we've built about where we came from traces back to this single image. And here's the thing about that image. It is almost perfectly uniform. Across the entire observable universe, 93 billion light-years in every direction, the temperature of the CMB varies by only about 1 part in 100,000. Tiny ripples. Quantum fluctuations from the very beginning of time, stretched to cosmic scale. Those ripples? They're supposed to be random. Statistical noise. No single region should be dramatically different from any other. The universe, at its largest scale, should look the same in every direction. It doesn't. In 2004, astronomers analyzing data from NASA's WMAP satellite were cataloging the CMB when they noticed something in the southern sky. A region roughly 5 degrees across, about 10 times the width of the full moon, where the temperature simply dropped. Not by much. We're talking about a fraction of a millionth of a degree. But in the language of cosmology, that difference is a scream. The cold spot is approximately 70 microkelvins colder than the average CMB temperature. That number means nothing in daily life. In cosmic terms, it means that region contains significantly less energy than it should. Less structure. Less everything. Scientists ran the statistics. The probability of the cold spot occurring by random chance within standard cosmological models is less than 1 in 50. Some calculations push that to 1 in 250,000. This isn't a measurement error. The European Space Agency's Planck satellite confirmed it in 2013 with higher resolution than ever before. The cold spot is real. So what is it? Astronomers proposed the obvious answer first: a supervoid. A region of space containing far fewer galaxies than average. And in 2015, a team did find a large void in that direction, roughly 1.8 billion light-years across. For a moment, it seemed solved. But here's what they didn't tell you: the void isn't big enough. Or cold enough. Or empty enough. The supervoid can account for maybe 10 to 20% of the temperature anomaly. The rest has no explanation. The cold spot shouldn't be this cold. And nobody knows why. Science doesn't like mysteries without answers, so the proposals came fast. Some physicists suggested the cold spot is the scar left by a collision with a parallel universe, a bubble of separate spacetime that grazed ours in the first fractions of a second after the Big Bang, imprinting a bruise on the CMB we're only now reading. This is the multiverse collision hypothesis, and it is taken seriously enough to publish in peer-reviewed journals. Others proposed a topological defect, a cosmic texture, a region where the quantum fields that shaped the early universe didn't settle evenly, leaving a permanent crease in space itself. There are models involving primordial magnetic fields, exotic dark energy fluctuations, even rare statistical flukes that, however improbable, aren't technically impossible. Each one has a problem. Each one either requires physics we haven't confirmed, Math that doesn't fully close, or probability so low it's essentially an admission that we don't know. But there is one more explanation, and it's the one that keeps theorists awake at 3 in the morning. Before we get to that explanation, you need to understand something even stranger about where the cold spot sits in the sky. Because it's not just cold. It's smooth. Unnaturally, almost suspiciously smooth. And when you look at the specific pattern of that smoothness under high-resolution analysis, it looks less like a natural feature of the universe and more like an absence of data. Here is the argument as physicists like Nick Bostrom and more recently cosmologists studying the CMB have framed it. If our universe is a simulation, a computed reality run by some intelligence or process we can't comprehend, then like any simulation, it has limits. Processing power. Resolution. The simulation wouldn't need to render regions in perfect detail that no observer is currently looking at. It would only need to maintain high fidelity where information is being actively processed. The cold spot, by this reading, is a region of low resolution. A part of the simulation where the rendering engine allocated fewer resources. It is colder not because of what happened there 13 billion years ago, but because that sector of the simulation is running on fewer computational cycles right now. This isn't science fiction. The simulation hypothesis is a legitimate philosophical and increasingly physical framework. Several papers published in journals like Scientific Reports have explored whether quantum mechanics itself, the fundamental randomness at the base of reality, is consistent with a universe that only renders detail when observed. The cold spot fits that model with disturbing precision. It is too large to be a standard void. Too smooth to be a collision scar. Too perfectly anomalous to be noise. And here's the part that lands like a stone dropping into still water: we cannot design an experiment to rule this out. There is no test that distinguishes a true cosmological anomaly from a rendering artifact. Not yet. Possibly not ever. So here is the full picture. The thing the title promised you. The CMB Cold Spot is a 1.8 billion light-year wide region of space that is measurably, confirmably, inexplicably colder than the rest of the observable universe. Every physical model fails to fully explain it. The supervoid is real but insufficient. The multiverse collision is possible but unproven. The topological defect is theoretically valid but unfalsifiable. And the simulation hypothesis fits. Not because we have proof, but because the cold spot behaves exactly the way a region of low computational priority would behave inside a rendered reality. Less energy. Less structure. Less detail. A corner of the universe where the physics is technically correct, but quietly, almost invisibly, incomplete. The universe handed us a map of itself 13.8 billion years ago. We've spent decades reading it. And in the southern sky, in a blue bruise 10 times the width of the moon, it may have accidentally shown us the edge of the code. The Euclid Space Telescope, launched in 2023, is currently mapping the 3D structure of the universe with unprecedented resolution. Its data will reach the cold spot region within the next several years. What it finds there, or doesn't find, will either collapse the simulation hypothesis or force us to take it far more seriously than mainstream science currently does. If Euclid finds the void exactly as expected, slightly denser with galaxies than the CMB data implies, we're back to square one. No explanation. Just an anomaly living quietly at the edge of our understanding. If Euclid finds the void emptier than any supervoid should statistically be, then the cold spot becomes the most important object in the history of human observation. Not a place in space. A seam in reality. We will know within a decade. That is perhaps the most astonishing sentence in all of modern cosmology. The universe is under no obligation to make sense to us. It has been here for 13.8 billion years, and it will be here long after every question we've ever asked has dissolved into background noise. But every now and then, it leaves a mark it can't explain. If this broke your brain a little, subscribe. we drop one of these every week. Next time, the Fermi paradox just got worse. Scientists found a star that appears to be surrounded by artificial structures, and the James Webb Space Telescope is pointed directly at it right now.